Hey folks, I'm back and I'm kicking off a new video series called 5-Minute Designs. One of the joys of owning a 3D printer is that if you have a good idea, you can turn it into a real-life object with just a little bit of time, some skill, and some 3D printer filament. If you check out my Thingiverse or Cults pages, you'll find designs ranging from car parts to kayaking and fishing gear to GoPro accessories, cosplay stuff, gaming junk. Heck, even the pop filter for my Blue Yeti microphone is something that I designed and printed myself. Now, most of these designs are simple. All of them use free software, usually Fusion 360, and you'll find a link for that below. So there's really no end to the things that annoy me in life. Therefore, there's practically no end to the things that I can design and 3D print to alleviate those annoyances. And like I said, these videos are probably not going to be 5 minutes or less. However, they will be succinct while still showing every step taken from idea to real-life 3D printed useful part. This is the Folger i3 kit. It's about 5 years old. It was my first printer, and it's bought as a kit. So every wire, every screw, every piece of aluminum, you have to assemble yourself. And as such, it's not a very refined printer. There's no enclosures for the electronics, there's bare wires all over the place. Even the LCD is just kind of hanging out in the open. So today we're going to look at one specific improvement, and we're going to design a piece to alleviate an annoyance with this printer.
What you're looking at here is the power supply for this little printer, and as you can see, this big black cable, that is mains power, is held on with just this little tiny zip tie. It doesn't hold it very securely, it can slide around quite a bit, and as it pulls tight, it puts a lot of strain on these connection points. So I'd like to design some kind of strain relief that will both keep the cable from sliding through so easily and putting strain on the power supply connections, as well as keeping it from rubbing against that sharp aluminum edge. So the first thing I'm going to do is sketch out the profile and take all the measurements for the face that we're trying to attach the strain relief to. There's no trick to this step. Use a ruler or a pair of calipers, whatever measuring device you have, but do be as accurate as possible, as the measurements you take here will translate directly to the sketches in Fusion 360 and thus to the 3D printed part. So here we are in Fusion 360. The first thing I'm going to do is create a new sketch. This sketch is going to mimic the side of the power supply unit. I know that it needs to be 48 millimeters wide and 27 millimeters tall, and that'll give us enough room to account for all 3 slots as well as a lip around it. I know that each of the slots begin and end 11.5 millimeters from the edges. I know that the first slot starts 5 millimeters from the top, and I know that each slot is 3 millimeters tall, 4 millimeters between them. So there's our 3 slots. The plan is for the cable to run through the middle of this plate, and then I would like to put zip ties through the top and the bottom plates, or through the top and the bottom slots. And then I'll have a zip tie gun going through the middle that'll secure the cord to the plate. So what I need to do is leave about a 5.5 millimeter gap on each side of these boxes, and that'll be the holes that the zip ties will go through. Now the zip ties are only about 5 millimeters, but pretty much everything you do, everything you design for 3D printing, you need to leave a little bit of a fudge factor, because even though your nozzle may indicate that it's 0.4 millimeter, and the nozzle actually is 0.4 millimeters in diameter, when the plastic is extruded, it can squish and deform a little bit. So whenever you're designing pretty much anything to be 3D printed, you have to leave a little slop in some of the numbers. So what I'm going to do, I'm going to extrude this bottom plate, and then these are going to be the holes for the zip ties to go through, and then I'm going to extrude this middle box in the opposite direction a couple of millimeters, and that'll give us a little ridge that'll sit in the middle slot on the power supply so that this little plate doesn't twist or turn or shift too much. I'm going to extrude this 4 millimeters. 4 millimeters is plenty thick. It's not like this thing needs to support a lot of weight. I'm going to extrude this slot in the opposite direction. 2 millimeters. So the slots are all rounded, so even though they may be 25 millimeters total width, there should be a 3 millimeter circle on each side, and that's because I know that the diameter of the circle should match the height of the slot. So I need to push back each of these sides by at least 1.5 millimeters to avoid the rounded edge. And again, since there's a little slop to everything, we're going to go ahead and move it back 2 millimeters. And then the same with the vertical surfaces. Add a little slop there. I'm going to do a 1/4 millimeter on each side, so that'll be a 1/2 millimeter of total touch factor. When we strap it to the power supply, this will go into the middle slot, and these two will align with the open slots. So now that we have that part done, we can take a look at the channel and create a new sketch on this face. And I don't want the channel laying flush with the top of the plate, because I do want to be able to feed through a zip tie under the channel itself, and then to tie the cable into the channel. So what I'm going to do is I'm going to start with 1.5 millimeter gap. And I know that the cable itself is 8.5 millimeters in diameter, but again, for a little bit of a slop factor, we're going to call it 9 millimeters. So the 9 millimeters for the cable, I want to have a 2.5 millimeter or so wall around the thing, so that's an additional 5 millimeters for the total circle diameter. So I'm going to create a 14 millimeter circle from here. And the diameter of the cable is, we're going to call it 9. This will be where our cable will go. And since it's a channel and not a tube, I'm going to bisect the circle. Then I'll only extrude the bottom half. Now if I were to drop these edges down, they would be flush with the edges of our plate holes for our zip ties. So that's the zip ties have that little nub on them that does the zipping. So I don't want to get them too awful close. I have a feeling everything will be kind of cramped if I start from there. So what I'm going to do instead is I'm going to project my holes onto my current sketch. And then I'm going to come in 1 millimeter from each side. And then draw in verticals from there. That gives us the profile of our channel. Oops. Alright, so there we have our channel, and we have our 4 holes for the zip ties. Next, I said I wanted to put a zip tie over and around the channel to hold the wire in place. So let's cut that hole out. Again, I don't want to put it flush with the bottom, so I'm going to come up, say 1.5 millimeters. We'll see if that'll work. That might be too much, but we'll try it out. And again, since the zip ties are 5 millimeters wide, I want to do a 5.5 millimeter wide gap. And in my experience, 2 millimeters is about right. that's enough room for a zip tie to slip through. Now we extrude that to the other side. Hopefully, we didn't cut into our channel at all, so we're pretty good with that. Now, if you recall, imagine this thing is sitting on the side of that power supply. The cable is going to come in from the bottom, and once it gets to the top, it kind of makes a sharp right, and then it splits out to the different poles on the power supply. So one of the things I wanted to alleviate was the sharp edge, the cable rubbing against the sharp edge of the aluminum. Kind of here, all I've done is replace the sharp aluminum edge with a sharp plastic edge, which is better overall, but we can definitely do better than that. I'm going to fillet that down by 2 millimeters, and that'll let that tube kind of bend without rubbing on a sharp edge. We'll do it on both sides just to be symmetric. So here we're kind of functionally complete. This, as it stands, this would serve the purpose that I set out for. It would hold the cable in place, it would zip tie down securely, and it would eliminate the sharpness of the edge. However, there's a lot of wasted material here on the sides, so we're going to go ahead and push these back a bit. Probably even go to 6. Yeah, that looks right. That looks pretty good. Now, when you're designing for 3D prints, right angles are often a bad idea, and the reason that is if you look at the profile of this piece, what's going to happen is that the printer is going to lay down a couple of solid layers here at the bottom, and then it's going to start filling this with infill, and you'll have a couple of walls on the outside, and then when it gets to the top of the plate, it'll lay down solid material here, but then when it gets to this corner, all you're going to get is a little tiny bit of solid material right here, just enough to support the 2 or 3 walls that you put vertically here. So there's just not a lot of surface area there. So on these 90-degree angles, it's a good idea, if it doesn't disrupt your design, to put in a fillet there as well. What you're going to get you're going to get what would have been just a couple of lines here to support these outer walls. You're going to get 4 or 5 of them on each layer, building up to this 2-walled vertical. So it adds support to these 90-degree bends if you fillet them a bit. So then, again, I think we're functionally complete. What I'd like to do now is maybe just round off all these corners just to give it more of a finished part look. Around these outsides. Pretty good. And then if it'll let us, sometimes when you fillet atop a fillet, it kind of freaks out a bit, so we'll see if it'll let us round these as well. I think that looks pretty good. I think that'll be our design. Once again, we'll strap it to the power supply in this orientation. We'll feed a zip tie through this hole, pull it out through this hole and tie it down, same on the other side, and then we'll feed a zip tie through the center and zip tie the cable into this channel. I think that'll work. I'm going to save. And then we're going to 3D print this. And occasionally, if you try to 3D print something too soon after saving or making significant modifications, you'll get an error. And what's happening there is that a lot of, some of the calculations that Fusion is doing are taking place in the cloud. That this is a connected application, and 3D printing, the conversion to STL, is one of the things that happens in the cloud. So if you save it real quick, that save, there's magic going on at Fusion, at Autodesk, that has not yet completed sufficiently for you to 3D print. So if you just go back in, try it again, there you go, not a problem. Didn't change anything, just Did it again. Alright, so that's done. We're done with Fusion. Next step is Cura. Here we are in Cura. I use both Cura and Prusa Slicer depending on my mood. I think Cura does a better job at finer, more detailed, smaller parts, because Prusa Slicer kind of wants to go crazy with like the overlap of supports. So if you're printing a small part, it'll print supports 3-4 millimeters outside of where the support's actually required, whereas Cura seems to be a little more restrained. But I like Prusa Slicer for just about everything except for that. But this guy here, I'm sure we'll probably actually see some weirdness on this part in both slicers as they try to like build towers and stuff for their supports. So here we go. It imported in the perfect orientation. We can't lay it flat on this large face because of this lip, so we're gonna have to print it. This seems like the ideal way of printing it. Slice it how it is. Take a look at what it popped out. Yeah, it looks like it did all the right things. As you can see, so here's kind of what I'm talking about. Cura chose to create a support tower to help out this bottom right support. It didn't do it on the left. This is a symmetrical part, so I don't know why it would choose to do it on the right and not the left. It looks like it thought about it real hard and put in this little, triangle thing here that literally does nothing. There's no use for that part. So I'm not sure why Cura makes those decisions. You can fool around with I think it's called support expansion in Cura. I have not found a similar setting to tweak in Prusa. But for now, this is fine. There's nothing wrong with the way this is sliced. It only put one line through that middle hole and no roof, so it's a small bridge. So even if there was no support at all, this would have been fine. But it's just not a very useful support in there. But we'll leave it. But otherwise, this looks okay. So we're gonna go ahead and send it to Octoprint. And in about 26 minutes, we'll have a print.
Here it is installed. As you can see, the cable does not move at all. And thanks to both the zip ties as well as our little ridge, the mechanism itself also does not move. So I would call this design a success.